A traditional product requirement document tells a team what a feature should do. For an AI product, that is no longer enough. The behavior is probabilistic. The failure surface changes with context, and a sentence like "make the assistant more reliable" gives a research team almost nothing it can reproduce. That is why Dianne Penn, Anthropic's first technical product manager, offered a sharp new frame on Lenny's podcast. Evals are becoming the new PRDs. This does not mean product strategy has been replaced by testing. It means the most useful product requirement is becoming executable. Instead of only describing the desired experience, the team captures real failures, defines what passing looks like, and creates a test that can be run again after every model, prompt, tool, or workflow change. The Eval becomes a living contract between the product problem and the technical system. Penn shared an early Claude example that makes the idea concrete. The team was hearing that Claude did not follow instructions. That sounds like a broad model intelligence problem. A conventional requirement might say, "improve instruction following," and then add several user stories. But the team read the failed transcripts one by one. According to Penn, roughly 80% of the examples were actually failures to return valid JSON. The problem was not one giant category called intelligence. It was a specific reliability pattern that could be isolated and tested. The team gathered roughly 30 to 40 failure examples into an eval set. Researchers could then change the model and run the same cases again. Penn said the relevant performance eventually reached about 99.9%. Those numbers are her recollection from the interview, not an independent Hunter benchmark. The more important point is the operating method. The team moved from a vague complaint to a reproducible failure class, and from a reproducible failure class to measurable progress. I would describe that operating loop in 4 steps. First, read the failed transcripts. Dashboards can show that something is wrong, but they rarely reveal the mechanism. A user saying the model ignored me might mean bad formatting, the wrong tool, a missing citation, an unsafe refusal, a memory failure, or a broken multi-step plan. The raw interaction contains the evidence. Second, group failures into themes that are specific enough to act on. Quality is not a theme. The model adds prose around a JSON object after being asked for schema-only output is a theme. Specificity is what allows product, engineering, and research to work on the same problem instead of interpreting the complaint differently. Third, turn the theme into a continuous, reproducible eval. The eval needs real examples, clear pass criteria, and enough held-out variation to prevent the team from simply memorizing the first cases. For deterministic requirements, a parser or rule may be enough. For judgment-heavy tasks, the team may combine model graders, human review, and targeted spot checks. The goal is not to force every product decision into one score. The goal is to make the important failure visible and comparable. Fourth, measure every intervention with the same instrument. Change the system prompt, switch the model, add a tool, redesign the workflow, or introduce a verifier. Then run the eval before and after. If the team cannot measure the difference, it does not yet know whether it learned something or merely changed the story it tells about the product. This is also why Penn argues that AI teams should sweat tokens as much as product teams once sweated pixels. Pixels were the visible material of software experience. Tokens are part of the operating material of an AI system. They reveal how context is assembled, where the model spends reasoning effort, when tools are called, and how much work is required to reach a stable result. Sweating tokens does not mean making every response as short as possible. A longer reasoning trace may be worth the cost if it materially improves reliability. A shorter trace may be wasteful if it creates retrees and human cleanup. The useful question is what the token budget produces. Token spend is an input. Experiment throughput and validated improvement are outputs. One team may spend a large budget on a single impressive demo. Another may use the same budget to run 20 small experiments, each with a clear hypothesis and a recorded result. The second team is building a learning system. That changes product cadence. The old sequence was often requirement, design, build, and final acceptance. AI products need a tighter loop. Observe failures, update evals, change the system, run regression, ship carefully, and collect the next set of failures. Every important production failure should become a candidate asset in the eval library. Every fix should leave a before and after record. Otherwise, the next model upgrade may silently reintroduce a problem the team believed it had solved. There is another reason a single PRD or benchmark cannot describe an AI product. Capability is jagged. A model can perform a sophisticated analysis and still fail a basic formatting rule. It can write a complete application and still make a dangerous permission choice. It can look excellent in a benchmark and fail in the exact context that matters to your customer. The jagged capability edge changes product design. Teams need to know which tasks can be delegated, which require checkpoints, which require a verifier, and which should remain human-controlled. Averages hide those boundaries. Scenario-specific evals reveal them. This is why a practical eval system is also a product architecture map. It tells the team where autonomy is safe and where the workflow needs structure. Penn's discussion also points to product overhang. Models may already possess useful capabilities that products have not yet made reliable or accessible. The limiting factor may not be the next model release. It may be the absence of a trustworthy workflow, a feedback loop, or a product interface that turns capability into a repeatable outcome. Teams that only watch model leaderboards can miss this gap. Benchmarks indicate what a model may be capable of. Production failures explain why users still do not receive the result. So what becomes more valuable for human product builders? Judgment, taste, proactivity, and hands-on shipping. An eval can encode a standard, but it cannot decide which problem deserves the team's next month. A model can generate many interface options, but it cannot own the taste behind the final choice. An automated test can reveal a regression, but someone still has to investigate why it happened and decide what trade-off is acceptable. Hands-on work matters because capability intuition cannot be built from status reports alone. AI product leaders need to use the model, inspect traces, write cases, change prompts, test tools, and build small prototypes. Using the model as a sparring partner is useful, but the point is not to outsource judgment. The point is to challenge assumptions more quickly and then make a better decision. Here is a practical operating template. Start the week with the most important failure themes, not a feature list. For each theme, collect 10 to 50 representative examples and write explicit pass criteria. Record the model, prompt, tools, token path, and outcome for every experiment. Keep a regression set that runs before release. After release, review new failures and decide which ones deserve promotion into the permanent eval library. Only then connect the evidence to a product change. The PRD does not disappear in this system. It evolves from a static document into an executable product contract. The narrative still explains the user, the strategy, and the trade-offs. The eval makes the critical behavior testable. Together, they give the team both direction and evidence. If you are building an agent, a support assistant, a coding tool, or any generative AI workflow, you can start tomorrow. Take the 10 worst user interactions from the last week. Group them into 3 named failure themes. Write an unambiguous pass condition for each theme. Run the cases before your next change and again afterward. If the score improves but the real interactions do not, inspect the eval itself. The measurement system is also a product, and it must keep learning. My conclusion is simple. The most valuable AI-era PRD is not the longest document. It is a system that can reproduce failure, measure improvement, and absorb new evidence continuously. Sweat tokens like pixels, manage evals like code, and keep human judgment close to the work. That is how an AI product becomes more than a demo. Follow for the next breakdown.